members and between task force members and SDOT staff on how we're proceeding in terms of the repair versus replacement decision, and how much information we have now to be able to start that thought process, since one of our two main goals is to advise the mayor on which of those paths we think makes most sense. So we have Heather with us. She made a presentation earlier about the Reconnect West Seattle and the bridge repair. And then we have a couple of other resource people with us. And Greg Izzo is one of those. He hasn't spoken to us before, so I'm going to ask him to introduce himself and the other resource people that we have available to us.
All right. Thank you, Mayor Nichols. Yes, again, my name is Greg Izzo. I'm the program manager for the West Seattle Bridge and overseeing all the capital delivery, which includes the Lower Spokane, the rehabilitation of the High Bridge, as well as the replacement of the High Bridge as well. So, with more individuals, they're individuals and employees with SDOT. There are structural engineers. I'm going to introduce Ling Te, who oversees our structural engineering group and our capital projects division in SDOT. Ling is a structural engineer, so she could help us with that expertise and be a resource. And Ling is also the senior advisor for the West Seattle Bridge program because she has the senior engineering, structural engineering experience. She is an advisor on the program. Second, we have Kit Liu, who is also will be speaking. It's all three of us the first time speaking here, so that's why I'm introducing Kit. Was with capital projects and still has a lot of knowledge from our capital projects delivery group. He used to manage project managers. He's also a structural engineer. And Kit is representing the roadway structures side of the house, the asset owner. Kit is now in that division. He'll be representing Matt Donahue today as the roadway structures director. And Kit is also overseeing the bridge operations within the division. And he is basically the engineering manager overseeing bridge operations and maintenance. So we have both sides of the house represented today, with Ling on the design side and Kit on the operations and maintenance side, as well as myself. Although I'm not a pure structural engineer, I know enough to be able to be informative, but I'm overall civil engineer. So we're going to try to answer all the questions that come at us today. And if we can't, we're definitely going to follow up with anything that we need to follow up with.
Let me just kick it off, Greg, and I don't know which of your members wants to respond to this, but we're due to have a decision in October, repair versus immediate replacement, or repair and then ultimate replacement. How far are we along in gathering the information necessary for us to give advice to the mayor and the mayor and council to make the decision?
That's a good question, Mayor. I think we're roughly at midpoint of the cost benefit analysis stage right now. We're wrapping up all the benefits portion of the CBA, and the next step will be to address the cost portion. So they're the two main areas that we're going to be focusing on to get us to that decision of repair or replace. The benefits, we just confirmed all of our attributes that we're going to be using to weight all the importance, the non-cost issues, meaning the benefits. And so we've just confirmed all the attributes that we're going to input into the tool. We can get that moving. The next step is to finish one more piece of the benefits, and that is for SDOT, mainly the technical experts, to numerically rate the alternatives against each attribute. And that's going to be a select group of people within SDOT who are mainly engineers who would be the best judgment of that work. So that's going to be wrapped up by next week. And then alongside of that, we're now reviewing. In fact, this Thursday, we have a workshop with our consultant who's going to be presenting for the first time all the cost estimates that'll be associated with each alternative, as well as the risks that we'll want to try to monetize and try to monetize or quantify those risks so that we can include them in the cost factors. And also we're going to be reviewing both the capital costs and the life cycle costs of all the alternatives. So that batch of information is also happening right now, and we're going to be evaluating that with the TAP next week as well. So that's up and running. So right now we're midway through, we're right on schedule, although it's still an aggressive schedule to have a decision of repair or replace by early October. We feel like we're on schedule right now, but we're halfway through the CBA.
Great, thank you. I think, Dan, you had your hand up in the chat thing.
Yes, thank you, Mayor. So I have a question about the replacement, or sorry, the repair options on the high bridge right now. I think some interesting information came up last session, or last meeting, around possibly 15+ year life cycle of a repair, and it sounded like possibly up to 40. But the TAP was not willing to go that far without a full year of expansion, thermal expansion information on the concrete. How do we make a decision on replacing a bridge before we get through a winter cycle of knowing if this bridge can last 40 more years? Because that seems like a game-changing amount of time to me personally, especially looking at small business trying to survive, and also our friends down at the port with T5 and making sure that that lease is enforced or comes together. Some clarity around that bridge is crucial, and the fastest way to get there is a repair, it sounds. How do we make a decision between 15 and 4, or between a full replacement and something that may last 40 years when we can't get that full year of out of the winter cycle, I guess we need? Can anyone enlighten how that works?
I could probably take a first stab at this one, and then you, Ling, or Kit, jump in if you feel. So over the last, since February, we've been monitoring this bridge very closely. And so we've already gone through at least one thermal cycle to see how the bridge performs. And that was before these stabilization measures that we're doing right now, the post-tensioning, the carbon fiber wrap. That was before those improvements were in place. We still want to retain the ability and leave that little bit of time at the end of the year to be able to go back and really look at how the bridge is performing once these initial stabilization measures are in place. That to us is too important to not monitor that and go back and check the results of how the bridge is performing, because that's kind of like the last check that we want to make sure that before we finally make a decision of repair or replace, we want to make sure that we're evaluating it at that time under that thermal cycle. So there's nothing to say that we can't pivot at any point. Even if we decide that repair is the best option in early October, we are still going to leave this small window open at the end of the year to be able to go back just to confirm our decision based on what we see out of the performance under the bridge once these stabilization measures are in. And so if we find out something much differently than we originally thought, we could always pivot toward the replacement. And that's the whole idea of making sure that our replacement option is moving forward right now, regardless of repair or replace. So even if we decide repair in October, we're still going to be going down the road of planning for a replacement, just to make sure that we have two concurrent processes moving forward and we're not losing time. I'm not sure that completely answers your question. If so, could you clarify a little bit more, or maybe?
Yeah, I guess the next part of that follow up on that is, how are we looking on this being repairable? Everything we're hearing is that it seems feasible, that they haven't found anything that makes it unrepairable. At what point are we going to get to that decision? Is that going to be October, or is that a little more analysis coming out next week from the TAP? Where does that? How do we continue to keep insight on this?
I don't think we could prematurely make a decision on that until the early October date for repair. And there is a span. I realize that there is a span between 15 to 40 years of service life out of a repair option. That's quite a gap. And so what we've been trying to do is dial that in to at least to have a more accurate picture of a smaller time frame, because 15 years and 40 years, huge difference there. And so we want to better understand. And again, this is through the monitoring of the bridge that's that's giving us the comfort level to say more toward the 40 years than the 15 years. So it's all about the performance and how the bridge is behaving right now. And we're going to need to continuously monitor that bridge through October. And then at the end of the year, once we get through the thermal cycle, to validate the timeframes that we select. And hopefully narrow those down, because it's right now it's all dependent on the behavior of the bridge. And that's what we're basing it off of. The 40-year life of the bridge is going to rely on ground improvements. So the 15-year life is mainly focused on post-tensioning, carbon fiber reinforcement, that didn't or the foundation improvements. But now the foundation improvements are part of that alternative. The consultant was comfortable enough expanding on the service life of that option. So I'm not sure, Kit, if you or Ling have anything to add to that, but again, a lot of it right now is just based on how we're observing the bridge and how it's behaving. That will really tell us later on with a different level of confidence where we'll be as far as service life.
Anne had a question.
Thank you. So I was thinking back on Deb Barker in the earlier session asked the mayor about a potential moratorium on construction, and it got me thinking about bridge capacity and comments earlier about how the bridge has far more weight and traffic on it than it was designed for when it was built originally. I'm assuming that you're taking into account some kind of number for capacity, either what we had before or slightly more. And I'm just thinking about how you make that decision when the current development rules allow continued construction and additional car trips in West Seattle. And how are you kind of weighing all of those things as you're looking at it?
Very good. Another really good question. So you're right. It was not designed to take on the current ADT across that bridge. However, that bridge has been able to accommodate traffic. And Ling, you might be able to speak more as far as the factors of safety that go into the original designs. However, I will say the replacement options right now are assuming the most current ADT levels. I mean, we're trying to do as much forecasting as we can as far as future traffic demands. But at this time, we're using the current average daily traffic counts and volumes as we analyze the repair options and the replacement options. So we're not going back and using the original counts. Furthermore, I just wanted to add that we're having a difficult time. This bridge was built back in 1984, I believe. And so we're still trying to gather all the records to make sure that whatever was designed was constructed that way. And we're having a bit of a difficulty right now confirming the as-built documents, the construction documents, to make sure that if there were 1,000 strands of post-tensioning that were supposed to go in, is that indeed what they put in? And so that questions like that, there's a difference in elevation on the structure itself that we're still investigating. So some of your question, I think, is going to have to rely on what the original design assumptions were and what the design was, and in fact what was built. And so that's a huge component that's been a struggle for us, but we're gradually getting there with enough information. But the average daily traffic will be based on current day levels and perhaps a future projection, but nothing less than that.
Commissioner Steinbruck.
Thanks, Greg. Following up on Ann's questions, I recall, and Greg is very familiar with this whole era of evaluating repair or replacement of the viaduct, of the Alaskan Way viaduct, and there was extensive forensic work that was done to evaluate its condition, its structural failures, soil, geotechnical, liquefaction, Also, the fact that it was built to a level that was really was substandard with regard to safety and other design aspects. But it wasn't until we kind of went through a fairly exhaustive, independent, peer-reviewed evaluation of the structural deficiencies of the Alaskan Way Viaduct. And I'm hearing at this point very incomplete information, including what we just heard, regarding what it was designed for and how it was built. And to make informed judgments about repair options, we've got to know more clearly and more confidently what goes beyond repair, but actual structural reinforcement, and maybe where it was under designed for the loads. What loads should we be designing for, and can they be done through structural, remediation, reinforcement, as well as repair? How suitable are the foundations for the added loads? And it's not just daily traffic counts, it's the heavy loads, I think, that probably are very much a factor there that maybe weren't anticipated. So I'm concerned that this is a decision point is a little premature in terms of repair versus replacement by October. Likewise, on the replacement side, what would we be replacing it with, and for what capacity? Do we want to accommodate? What about ST3? And how do we take, into full consideration, if we're starting over, a more efficient approach to accommodating transit needs there? So I would just personally caution that we really are not, we will not have the full information and confidence by October to make a thumbs up, down decision on repair versus replacement. And I guess that's what I would put forth there. And I think it's an iterative process, and it continues to build on evaluations, comparisons, cost comparisons, life cycle, the life of the structure that we would be ending with, all of those different things, future growth of West Seattle. So anyway, I guess that's just an open question.
Sure.
I could go on, but I'll stop.
It does seem to me that the October time frame is important, because people are, we're at day 149.
Yeah, get on with it. Yeah, I understand.
So people need to have some certainty in their lives that at some point this will end. And I think that our advice to the mayor in October is not going to be, yes, this is the repair. I think it's going to be that it can be repaired, the experts tell us, and it can be repaired in such a fashion that its utility, the cost, and the duration are such that we think that's worth pursuing, as opposed to an upper. I think it's a more nuanced decision.
Do we know, I expect an environmental impacts review will be required for the options. That's supposed to inform reasonable, alternatives. So how does that get considered?
Can I just jam myself in here really quick? Yes, of course, full environmental documentation is going to be required. I just want to gently remind everybody that the viaduct, we didn't ever close it down, right? The viaduct kept operating and kept, yeah, I remember, but it kept carrying traffic. And so we had, in some ways, the luxury of time to do that forensic analysis. Also, the viaduct showed real problems, kind of the full length of the structure. Our problems on the West Seattle Bridge are a lot more localized. So while I agree that it's always nice to have full forensic information before we move forward, as a resident of West Seattle myself, and also as the program director for this program, I don't think we have the time to have that full forensic analysis. And I agree with Mayor Nichols that we, SDOT, and the mayor is not looking to this team to make structural engineering recommendations or recommendations about how we might repair or replace the bridge. So I absolutely hear, and I work with a lot of engineers. I understand the desire to understand a problem fully before we move forward, but I don't think we have that luxury right now. Greg or Kit or you, Ling, did you have anything you wanted to offer?
No, I think you hit it. Obviously, stay on a schedule, set our schedule, stay with it, but knowing that we need to continue monitoring the structure even after the decision. Again, going through the winter thermal cycle. So, but it was important to stay with the schedule and at least have a date, a time frame for that decision for repair or replace. We, even if we know if it's feasible, is it advisable to repair it? I mean, that's really the main question, because if we decide to put traffic back on, we want to make sure it's effective in that we're being able to put all the live load traffic back on the bridge instead of just a small portion, or that we're not phasing it over many years to get the full live load on. So it's almost going to come down to, is it advisable? Because we know it's doable, but the last thing we want to do is put traffic on the bridge only to find out something happens in a year where it's not behaving like we did and we have to remove it, remove traffic again. So that's the piece that we're trying to avoid, is that kind of headache down the road. So we want to be obviously sure of our decision.
We want to measure twice and cut once. Amanda?
Exactly.
Amanda?
Yeah, thanks. Hey, question. If we end up doing a repair, would we consider load limits on the high-rise bridge or weight limits?
That is a really good question. I would only say off the bat that we would try to avoid that. Our goal right now is try to restore live load to the current volumes, the current vehicle trap classifications,
Greg,
and not go there. But Heather might have.
Greg, no, this is what you and I were talking about just the other day about HL
93.
93. Yeah, so there are federal standards that we have to design, that we would have to design anything to. And so Greg, maybe in layman's terms, talk about HL 93.
So the HL 93, and you Linger Kit or the structurals, they can jump in if I'm going off here, but the HL 93 is an AASHTO set standard we would adhere to, and we would normally not go below that standard. So all of our bridge structures would theoretically, especially of a corridor such as this, would be designed to the minimum AASHTO standards. So going below that would be a decision of deviating from the AASHTO standards, which is something I can't recall we ever did. But Linger Kit, do you have anything to add on HL 93 loading for bridge structures?
This is Ling. I just wanted to clarify that the HL 93 load is.
Oh.
Hello?
Yes.
Okay. So the HL 93 load is per current AASHTO, which is a national bridge design standard. The bridge that was originally designed was with another older version of national truckload. So we are going with the current national bridge design standard, as well as this bridge is a long span bridge. So it also needs to be designed for accordingly, because this is a so-called long span bridge, which means is unlike a normal bridge where this bridge has farther distance apart between the supports. So there are more loads that need to be designed for the bridge.
So Ling, does that mean that a repair would have to meet the modern
Yes,
standard?
that's correct. That's what we are trying to follow per the current code.
And this HL standard,
93.
is that for the wide loads that are now prohibited from even the low level bridge? Or is it something else? What does it look like? What is a load that makes that?
So basically, it's a legal truck load. It's not an actual load, but it's a notional load that the national standard describe such that it can envelope all the trucks, most of the trucks, not all the trucks, most of the trucks commonly used. If we design for this load, supposedly we will capture all the other truckloads except for the overlegals.
So
that
So let me just narrow that down a little bit. So we have quite a variety of freight that crosses the Duwamish. The port traffic, when T5 reopens, I assume will continue to use the low-level bridge. It's very convenient. They have their own access to it. So that's not a problem. But the steel plant, I have to think that those rebar loads are the heaviest thing that you see going across the high-level bridge on a regular basis. You shaking your head there, Heather?
Oh, yeah, they're still legal loads though.
There might be, but they are extraordinarily heavy.
Oh, sure, they're heavy. But they have to be carried on a truck that it falls within these standards. Over legal loads require, they're so big, so long, and so unbalanced that they require a permit to travel through
Like
the
a
city.
pilot car and stuff like
Yeah.
that. So
Yeah.
the steel plant, and I'm only using it as an example, that's not a concern. That doesn't wear a bridge out faster than a normal delivery truck that's going to and from Husky Deli.
Buses.
Buses too, yeah.
Yeah. Frequency.
Okay.
It really depends on frequency of as well.
Yeah, sure.
If that's a once a year load that goes across, that's one thing. But if it's an everyday constant moving across a bridge of a structure of a truck that heavy, then it's a frequency issue, and it could become an issue. So I think it's a frequency question.
Okay. Peter, Peter Goldman you get the last question because we're supposed to reconvene in about 2 minutes in the larger group.
It's not, I just want to, I'm just updating on the Sound Transit crossing as well. I mean, designing a load for status quo is one thing, but if we're really going Sound Transit, I just want to know a little bit more about where they're at as far as their schedule and what kind of crossing they would prefer to be on.
Okay, so
there might not be enough time for that right now, but I mean, that's just what pops into my mind.
So there are 3 of us on this task force who were part of Sound Transit's process over a year and a half. Myself, Deb Barker, and Aaron Goldman, or not Goldman, Aaron Goodwin. And so we have a year and a half of experience in meetings like this, only in a single room. And Sound Transit's goal is to have their crossing as a separate crossing by 2030. None of our timelines get out to 2030. So I don't think they probably have the cash flow to be able to move that up. I certainly don't think they'd be able to deal with a repair. I just can't see the engineering that would allow such an increase in forces, not necessarily the weight, but the force of a light rail train is different and needs to be accommodated in the design. In a replacement, I guess, if we have a 15-year life of a repair, I guess potentially at that point, whether they should be on the same bridge or whether we want to have some redundancy built into the system is a fair question and needs to be asked. But I think it's only that option that really they come into.
That's correct.
Okay, with that, let's exit this. go back to the big group for report back. I didn't ask anyone to do the report back. If there is there a volunteer? If there's a volunteer, great. If not, I'll do it. I didn't see any hands go up. Okay, all right. And you can give me your feedback later on how accurate I've been. Thank you.
All right. See everybody on the other side.